Now to go over adaptive gradient descent, or the adaptive gradient algorithm, AdaGrad is an algorithm for gradient-based optimization that adapts the learning rate to the parameters. So, gradient-based and adapts the learning rate to the parameters, performing larger updates for infrequent and smaller updates for frequent parameters. Perform larger updates for infrequency for infrequent parameters and perform smaller updates with frequent parameters. It is particularly suited for dealing with sparse data, so great for sparse data. The benefit of AdaGrad is that it eliminates the need to manually tune the learning rate, as we discussed before. However, its accumulation of the squared gradients in the denominator can lead to excessively rapid decrease in the effective learning rate. And it can prematurely converge to suboptimal solutions, which is why it may not be well suited for training deep neural networks, but it is good to be able to know whenever we have sparse data that we can use the adaptive gradient descent if we need a quick means of classification. So it's faster for optimizing classification, trade-off with speed and accuracy. And to go over the following symbols to help break down, it will be the following. Let me just move this up. All right, the following symbols will be for AdaGrad. So G of T I is equal to the sum of squares of gradients with respect to theta up to time step t, and then mu refers to, as we know, the learning rate. Epsilon is a constant. Constant to prevent division by 0. Similar to the root mean square propagation. And finally, G of t lowercase. So we have this symbol right here, g of t. With respect to the input, it's going to be the gradient of the loss function with respect to input vector and at time step t. Let me just clean this up for you folks. And now let's move over to our next part, Ada delta. And so yeah, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.